screen?
Yes.
Okay.
You put it in presentation mode?
Yeah, I'm doing that. Okay, so we don't need to wait, right? I suppose we can start.
Yes, we can get started.
All right. Okay. Well, thank you all for joining this webinar. I hope you find it useful. Today, like Anna mentioned, we'll be talking about leveraging a Bluemix service called Insights for Twitter. Use PySpark to perform some data transformations, creating data pipelines, and then finally using Python packages like stats model and scikit-learn to create a model and try predicting daily collections for movies. Um, so moving along. So my name is Rajesh. Sorry, my name is Rajesh. I'm part of the North America technical sales team for IBM and looking into big data primarily. So here's a quick agenda. We briefly hint upon what the big insights, IBM Insights for Twitter services, a very brief introduction about Spark, some of the modules that we use out of Spark. We also will talk about what IBM's contribution is. And finally, IBM DSX, which is a data science experience where we all bring these things together. And finally, about what the use case exactly would be. So Insights for Twitter is one of the Bluemix services which provides Twitter content, but at the same time it uses deep natural language processing and provides enrichments like sentiments, geolocation, the gender information, and things like that. There are two different models out of for the Insights for Twitter service. One is a Deca host, which is 10% of the tweets, all coming from GNIM. And then the power track where you actually can create a topic and start monitoring it in a real-time basis, on a real-time basis. And I did have, so I'm sure these slides will be made available. So you have added the links to get more information about what each of these mean. For this example, we will be using the Deca host, which is the historical 10% of the tweets because we want to look at we're going to look at movies which was released in 2014 and 2015. So and these services are available via REST calls. So at the bottom of the slide we have examples of how to perform the searches. So in this case it's you're trying to get the tweets based on the keyword IBM and that was posted between two dates in 2016. So the first example is the real URL, and the second is the encoded version of that. You need the encoded version to perform the HTTP request, and we'll look into that as well. Spark, we all know it's one of the most popular open source projects. There are four. At the bottom is the main Apache core Spark, and then there are four major components of that: Spark SQL, streaming, MLlib, and GraphX. We'll be using one of these, which is the Spark SQL, to perform the data transformations and pipelines. And it's extremely useful and very simply used. As long as you know SQL, you should be able to leverage that. Moving along, a quick slide about what IBM and Spark, how they go together. So IBM has heavily invested into Spark, and you can look at these links, which is the Spark Technology Center website, which talks about the different JIRAs that we have been committing, the different modules, the Spark components that folks from IBM have been working on, and what are the contributions that is going from IBM towards open source. In addition to all these, there's also heavy interest or focus on using IBM products starting to use Spark. So there's a whole different level of adoption within IBM for Spark. Um, and just one more slide about that talks about what IBM contribution to Spark. The recent 2.0 was IBM was the second highest contributor for as part of in terms of the issues and the code contributions towards Spark 2.0. So definitely the investments are starting to show fruit. The two components that I mentioned that we'll be using out of Spark, or well, the Spark SQL is the main component that we'll be using. So Spark SQL provides a schema layer on top of structured and semi-structured data. It is one of the Spark modules which has got great traction. IBM being one of the greatest contributor for this, in addition to Databricks. as long as you know SQL, it is very straightforward to start using and manipulating data, and it leverages the catalyst optimizer of Spark, so you can be rest assured that the query plans are well optimized for processing. We will also be using PySpark, which is an integration, which is a Python binding for the Spark platform. So you folks who are familiar with Python can easily leverage the Spark platform and perform the big data analysis using even by staying inside Python, but at the same but calling Spark APIs and performing the data manipulations needed. There's very close integration with Python. You can convert data frames, which is a Spark concept, a schema or across a schema layer on top of your data, and converting data frames to pandas, which is the Python component. And so back and forth, it's pretty straightforward to use to convert data frames to pandas and vice versa. And we will be leveraging that in our notebook demo. And finally, the IBM Data Science Experience, which brings a host of tools in under one umbrella. So be it Jupyter Notebooks, RStudio, Watson Machine Learning is coming soon, all in a single place. So folks who are familiar with the respective tools can start using those, integrate with Spark, and perform their machine learning or data science experiments. So it is definitely one of the tools that I encourage folks to sign up. There's a rich community out there. There are a lot of public data sets available, a lot of notebooks available. So it's very easy to learn and make use of that. In addition, there is the concept of collaboration, where your notebooks where multiple folks can work on the same notebook. It can be shared and worked upon. So it's definitely something that I encourage folks to sign up. And again, the slides has the links that can get you started pretty easily. And finally, on the use case that we will be covering today, it's all about movies. We love movies, and we all know that Twitter plays a very important role in today's world when it comes to social media analytics. And the tweets or the sentiments expressed does play a role in some form in the success or the failure of products or movies in this case. So the idea was, based on the sentiments that is available, is it possible to create to measure that and create a model that can predict the daily collections, and once the model is created, can that model be applied to related movies or sequels, and how close can we come to the truth or to the actuals? So in this case, we will be using I'm using this movie called the movie that came in 2014 called The Maze Runner, and we got the daily collection data from the website that's mentioned, Box Office Mojo. It's a great website. It provides all the information about how the movie performed across all the days. There's a lot of it won't be a big data problem, definitely, but there is a lot of data available in terms of the daily collection. Incidentally, the Maze Runner 2 came around the same time in 2015. So we will measure the sentiments that was and create a model based on the earlier Maze Runner, try to apply it to the Maze Runner 2 and see how close we were to the truth. So again, the collection information is I didn't do any much of work. It's thanks to Box Office Mojo, so all credit to them. So with that out of the way, let's look at the notebook. So Anna, we'll take questions at the end, I suppose, right?
Yeah, we have no questions right now. If the questions need to be answered, I'll interrupt you. If not, if they can be left towards the end, then we'll leave them towards the end.
Okay, all right. Thank you so much. So here we have the DSX, the Data Science Experience. Created a project and a notebook within that. So like I said, you can use your familiar Python or RStudio the languages that are the most popular ones for performing machine learning type work in the DSX environment. And you have the ability to share the notebook, so work collaboratively, look at information that is available, all within DSX. You don't have to leave the DSX environment. So like I said, so these are the information, these are the components that we're using, the Bluemix Insights for Twitter service and DSX to create this demo. And for the URL that I talked about, you need a user ID password. So once you sign up for the Insights for Twitter service, in this case, this is the decompose, like I said, about the 10% of historical tweets. You can provide the dates that are of interest and the specific keywords. Like in this case, I'm giving the keywords for Maze Runner, the actors in that, the person who wrote the novel, James Dashner, all within the time period of interest that we want to measure the sentiments that were recorded. So that's the raw URL. This is the encoded version of the same URL. And here we start looking at the code of how we get the Twitter data by invoking the Insights for Twitter service. So it's a pretty straightforward REST call. I'm using Python here, making the REST call and writing it to files locally. Same way for so this is for the Twitter. These are the Twitter feeds. This is just for one particular month, so which is 2015 January start to end, because that was one of the times where we have the data, the daily collection data for this movie. And same way, this is for the second movie towards the end of so November of 2011. So I made multiple requests by changing the dates. So I collected multiple files. And here the listing of the files. So I have created a directory for Maze Runner 1 and Maze Runner 2, and these are the files that got created based on the request that was sent to by changing the date ranges. And sorry about that. So this is the information about the box office Mojo sites from where the data was collected. There are APIs available to retrieve the daily collection data. So that's how I got the daily collection for the two movies as a CSV. Not a whole lot of cleaning up to be done. It was pretty straightforward to start using it. So we will first begin with analyzing the sentiments for Maze Runner, the first movie. This is again using PySpark. You get a SQL context and you start reading the JSON that we collected earlier by making those multiple requests to the Insights for Twitter service. Notice that the Twitter the data that comes out from by invoking these services are in JSON format, and the tweets are an array of tweets. So and that's exactly what I'm trying to look at the data that I got from these from the REST calls that were made earlier. And these are all there is information. There's a whole slew of information that comes out of the. So in addition to the tweets, there is information about the person who tweeted, the sentiment information. So the sentiment part, the polarity and stuff like that, which is what we will be using in our in this particular use case. So like I mentioned, the tweets, the various tweets that come along are as they come as an array of tweets, and you need to explode that to get to the individual elements within the JSON. And that's exactly you can, and using PySpark and the SQL context, you are able to get to each and every element to that granular level and get the information. So in this case, I am actually interested in getting the body, the time that the tweet happened, and the sentiment which the Insights for Twitter's service provided to us based on analyzing the tweet. And we look at what are the types of tweets that came out of this. So notice that this can be we can use the dot notation and get to the tweet element, or you could use simple SQL, which is exactly the same that we did before. So now in this case, I'm using a simple SQL to get the same information that we received using the dot notation. So again, either using the programming model that you're familiar with, either using SQL or not, you are able to get the same information now. So what we do is, once we get that information, I'm registering as a temp table. So now onwards, I am able to leverage SQL, which is the most commonly used language, and then start using and start analyzing the data to find to ensure to make sure that we have the data that we need in creating the model. So in this case, I'm just doing a simple count. I know we have 14,800 rows out of the tweets that are available after exploding. Now again, to reiterate, this is not the amount of data that we're talking about is not at all a big data problem here, but the methods and the tactics that we use can easily be leveraged on big data, because this uses Spark, and if you have a significantly large cluster, you should be able to use the same methods to work with your data.
Rajesh, there's one question.
Sure, go ahead.
About the sentiment field. Who, what, or how is the sentiment field generated? Is it provided by Twitter from a black box, or how do you get that?
Sorry. So the question is who sent the data?
How do you generate the sentiment field?
Oh, so the sentiment is generated by the Twitter Insights for Twitter service. So if you go up, let me just show you the JSON. So all we did was make the REST call to the Insights for Twitter service and provided the date range and the keywords. And Insights for Twitter service has already measured the sentiment out of that, and that's what it's providing. So this is all. So I didn't do anything. This is actually provided by the Insights for Twitter service.
Thank you.
So, and you can. I mean, there is a whole bunch of here. If you look at, these are the details of what the Insights for Twitter service is, how to use it, what is the plan for pricing. There is a free version as well. But yeah, a whole lot of information comes out of the Insights for Twitter service. So yeah, I did not have to. I mean, there are other ways of doing it where there is a Watson sentiment analysis service as well. So you could take this tweet, send it to the Twitter, send it to the Watson sentiment analysis, and then get similar sentiments out of it. But in this case, this was already done for me, so I didn't have to do. So the whole idea was how easily you can leverage existing services and come up and try to solve use cases that are relevant. Okay, hopefully that answered the question. Okay, so moving along, so we did go over this. We did explode. We got the different sentiments out of that. We did a count to see how much of tweets are available. The next thing we do is since we have the date that we got from here, we need to extract the date, the year, the month, and the day out of that, so we can combine it with the daily collection data and then and create a joint table out of it. So we do that. All I'm doing is just simple simple function calls to extract the year, the month, and the day from the timestamp that was available. Also notice that we start seeing the different sentiments that also came out of that, right? So if the Twitter service, the Insights for Twitter service, was not able to identify any sentiment, it gives you a none. That there was no sentiment, that if it's a generic sentence, it couldn't figure the sentiment out of that. It will give you that. Ambivalent would be something like a conflicting one. For example, it would be something like, oh, I really love the novel written by John Dasher, but the movie is not good. So in one sentence, there are actually a positive and a negative. So that's what ambivalent would be. A neutral would be saying, I'm a Star Wars fan. I really don't care much about, or I'm okay with watching Maze Runner kind of. which doesn't sound a whole lot positive, but there is some sentiment that can be leveraged out of that. And then, of course, the positive and negative we all know. Finally, next we do some verification just to confirm whether the data that we really got out of these matches all the months of interest that we have from the daily collections. So we know that the movie got released in September, and this is the information from. Oh, this is the site that I got the information from. And here, these are the movie collections. So we know the movie is released in September, and we have daily collection data of till January. So we want to make sure that at least we have that from the tweets that we collected have the same months, so we can do the perfect join and have a one-to-one relation out there. So we have, so we did get September, October, November, December, and January. So the data seems to be relevant here. We also look at how the distribution of sentiments are. So we see neutral seems to be the most prevalent. There is some positive, ambivalent, and negative, and none as well. Notice that these information, if you look at the table so far, we collected the year, month, day, and the sentiment column. Now all these sentiment columns are all interspersed. We need to make sure that they all can be transposed or can be pivoted to get something like this, where for each day we have a distribution of neutral, ambivalent, and all the different sentiments possible. And using SQL is pretty straightforward. Even though the SQL looks a bit long, but all we're doing is just grouping by the date. We do a count on the different sentiments and make them as columns. And that's all this SQL is doing. So at the end of this C statement, we get what we need, where we have the date, we have the different sentiments all grouped, and a single entry for that. This is a very powerful thing that can be done. If you want to do programmatically, it would be a whole maybe a one page of code. But using SQL, it is pretty straightforward and definitely portable across platforms. So we have the sentiments available. We also look at the daily. Next we look at the daily collections data, which is with the CSV that we had retrieved from the Box Office Mojo site. We look at the first the daily collection for the first movie. So notice again, this has a day, this has a date, it has the daily gross collection, and the release day number, which is, so we have 126 days of data, and that's what it is. So the release date does matter as well, and we will be using that in creating the model. So something similar what we did before. We will retrieve the year, date, month, because that's what we did for the earlier part, and then we can do a simple join across the two tables. So from the daily collections, we retrieve the year, month, day, and the gross value. So rest all the columns remain the same. We're not even touching those. Now, once we have those, we will perform a join between the sentiment table that we created. Notice that whenever we do this, doing the joins on it, we retrieved, like for example, in this case, we are registering it as a temp table, and by registering this as temp table, you are leveraging the SparkSQL method, the functionality. You are able to leverage the SparkSQL functionality and perform these simple joins. So in this case, we are joining the sentiment and the daily collection tables. It's a pretty straightforward join on the year, month, and date, and that's what the information from the Twitter and now from the daily collections. There is data available on both sides, so it's easy to make a simple join across these two tables. Next, we do a simple checks to make sure that the data that we collected from these join tables exists for the 126 days. So we know that from the maze data there is 126 days of data, and same for the join table as well. Again, notice that we have registered it as a temp table, so you're able to perform these simple SQL functions here. So now with that, again, some more checks to make sure that the months, nothing got dropped, the joins were perfectly, we got the data that we needed. So notice that we have the same months that was available in both cases. Next, we are ready now to create to extract columns that are of interest and then create a model. So we know the gross is the dependent variable because that's what we are trying to predict, the daily gross. Release day number, which is the days number after the release date, and which we get from the last column here. From the last column, so the release, the number of days after the initial release, the original release date, and the different types of sentiments. So we have the neutral, ambivalent, and all those. These are all columns now. So it's easy now to create a model since based on sentiments, based on the release date, and then we can try to perform a prediction of the gross collection for each day. This is the join data. We selected the gross and the columns that are of interest for now. I'm just doing. So remember, I mentioned about how easy it is to integrate between Spark and Python. So you can convert your data frames into pandas and perform functions that are specific to the Python pandas. It's a very powerful feature when you're working with data or investigating and looking at it and trying to explore things out in the raw data format. So that is again an example to showcase how conversion can happen from the data frames into pandas and do a head of that or a tail of the data frame. We look at the status.shape. It tells you how many rows are available. So there is 126 rows available. There are 7 columns that are available. Next, we use the stats model package, which is part of the Python, one among the many commonly used Python packages. So we import that. We create the linear regression. We call the function for that. The methodology to provide or the syntax to provide this would be the gross would be the dependent variable and this whole slew of columns to be the independent variables. So you have the release date, neutral, ambivalent, positive, negative, and none. These are the different columns that we created or we extracted out from the Twitter feed, and we create LM is the model that got created. We can print the coefficients. It's again now once in this case there is nothing running on Spark. We got everything into Python, and now we are using Python's infrastructure to create these models. We are all we use Spark at that earlier stage was to perform this data pipelining or the data transformation part. So these are the intercepts that are available that got computed. Notice for the coefficients for each of these independent variables are also printed out here. This is just a summary that tells you the different statistics related to the model. It's a least square methodology that was used, and we get to the fun part of now predicting the gross value based on the model that was just created. So we create a new column called pred. We provide the same data, the pandas frame that was created earlier from the 7 columns that was selected after the join, and we try to plot those. We do notice that there's some amount of overestimation, but definitely decent. But it overall it does try to follow the trend from the collections, from the actuals as well as the predicted one. So there are a lot to be tuned. I'm sure that you could start looking at each of these independent variables, see what could be dropped or what could be enhanced. For example, can the gender play a role? Can the weather can the weather play a role? Can the geographies play a role, or can the language in which the tweets came, can that play a role? So we're not going to get into those for now. We will just use this as a simple model to begin with. It's a decent start. Not the best of fits in any case. As you can see, there is definitely an overestimation that is happening. So if you do a computation of the sum of gross, that was the actual, and the sum of prediction, we see that we do overestimate by so this estimated around $101 million, and this estimated around $124 million. So about a $20 million overestimation, and we try to plot that. The SG is the actuals, and SP is the predicted ones. And we just showing it in a nice readable format. So like you can see, it's 101 million was the actuals, 124 were the predicted ones. How about we apply the same methodology on the part 2 of the sequel of the movie? We do similar process where the sentiments, the Twitter feed was already, the insights for Twitter service was already called. We did get the data for different time ranges after the release date. So we follow the same method. We explode the tweets. We retrieve the year, date, time from the tweets. So exact same method that we used earlier. In fact, in this case, I accidentally had an extra set of months, and it will definitely get dropped because there is no join condition when we look at the daily collection data as well. So we have the data available for the Maze Runner 2 or the Scotch Trials movie, and then we do the similar exact same methodology that we followed. We do a distribution of the tweets, of the sentiments of the tweets. So pretty much looks like there's more none this time, and no neutrals, and positives and negatives have fallen, which does indicate that the collections of this will be bad, will not be up to the mark as what we had before. And the same exact thing where we pivot the data. Remember, we got the sentiments, every interspersed in one column. Now we get that as individual columns for the same date, and for the same date. We next read the daily collections data, the Scotch Trials, which is the sequel collections data, which is available again, same location, Box Office Mojo. It tells you the release date and the day after how many data points they have. So in this case, they have 112 days worth of data, and which is what we should be looking at when we do the verifications. So okay, so we read the collections data. We do a merge or join between the sentiment. This is sentiment for the second movie and the collections data for the second movie. Exact same method. So I'll just skip over all these. We now do checks. We want to make sure that we have data. It has which is 112 days of data in the join table as well. So this is the raw collection. The collections data and as well as the joint data table has the same exact number of rows. So we know that data has not been dropped. We have the sentiments available. We can perform more verification just to make sure that the dates after the release and till the date where the collection is available, all the months of data exist in the data set, in the final data set. Now with those in place and the model that was created before, we can select the columns, create a pandas frame out of that, and apply the prediction on this data pandas on this set of data, new data, which is for the Maze Runner sequel, and do a plotting. Again, if you notice that it does the trend is pretty much similar to what we're not able to get the initial spike after the first release, but pretty much after that, every little spike it's able to follow that. Again, in no means this is the perfect model. it is a decent start, like I said, and we do a gross of these, of the gross and the predicted one. We noticed that the gross, it actually in effect it made $80 million, and the prediction was for $91 million. Still slightly better, but the trend did get captured. And here we plot it, doing the for the total collection, and a much more readable format where it shows 80 million was the gross, and 91 million was the predicted one. Finally, I also try to do this exact same thing using the scikit-learn, just to see if the model that got created with this has any change. And if you notice, so this is exactly the same thing. I select the columns. I created data pandas for the gross and for the columns for the independent variables. And if you notice, this is exact same intercepts and coefficient values, just to confirm that the two different packages brought exactly the same results. So again, this in no means was a big data problem, but it was to showcase how Python and Spark could be integrated, models could be created. Even you could use the same methodology and do the entire thing using the Spark ML lib as well. But since the data set was pretty small, and my environment for the cluster environment is kind of smaller, I chose to use the Python packages to create the model. So that's all I plan to cover, and I'm open for questions or suggestions. Or so Anna, if there are questions, we can take that now.
There's a couple of questions. The first one is about Bluemix, and the question is there a free trial period on Bluemix?
So for the insights, I know there's no free trial period as such. There is a limit on how much tweets can be retrieved. So there is a limit on that with the free, unless you pay for and get a larger tweet retrieval amount. Okay. What's the next question?
The next question is off topic. Just curious, what kind of ThinkPad are you using? How much RAM?
ThinkPad. Oh, my ThinkPad, this one. Yeah. Well, I think it's about 16 gig, I guess. But I'm not using any of my local resources. Everything is on the cloud. I'm using Bluemix. I'm using the Data Science Experience, which is all hosted. So nothing is running on my machine.
Next question is, I saw you were using Python 2. Does DSX support Python 3? And what is the latest version of Python that's supported?
No, so as far as I know, only Python 2 is supported. I know there is things are on the roadmap to support the next version of Python. And what is the follow-up question?
What is the latest version of Python that's supported?
Oh, I think, yeah. So I think it's 2.7 is what. But yeah, I think, but I'm pretty sure there is efforts on to get onto the latest one. I mean, you also notice that I'm using Spark 1.6, but the same thing should work on Spark 2.0 as well.
Okay. Can you please revisit the PySpark part of the presentation?
So the PySpark part comes where so you get a SQL context or through the Spark context, and at this point, whatever invocations that is happening, you're actually invoking on Spark via Python. Is your main, you continues to be your main coding environment, but you're by calling these libraries, you are invoking Spark to do the processing. Same way for the tables, when you start registering these temp tables. You could start executing the SQL. They're all in leveraging the Spark environment. So I'm not sure how many folks already have the Data Science Experience account, but when you sign up, it also asks you to sign up for a Spark cluster on Bluemix. So, and that's how these things get tied up. When you create a project, you have to provide information about your Spark cluster, and so all the code, everything runs on all the Spark information runs. Anything that is related to Spark runs there. That's all good Bluemix. So nothing is hosted. Everything is hosted. Nothing is in your local environment.
Okay, next question is, what is the difference between using PySpark in Bluemix versus Anaconda?
I don't think there should be any difference. PySpark should be, as long as the libraries are available in Python, it should be, there should not be any difference. The Python version would matter. If you have an earlier version, you may run into issues. If you have the latest version, you may run into issues, but yeah, as long as the Python version, the major level is consistent, there should not be. At least I have not seen. I have used Anaconda as well.
Okay, and the next question is, do you have a date when Python 3 will be supported?
I don't have a date, but we can try to find out.
Okay, yeah, we can find that out, and we'll get back to you individually with that answer. Are there any other questions? I don't have any more questions right now. No, I don't think there's any more questions. So thank you everyone for joining us today, and thank you Rajesh for your presentation. As I mentioned before, the webinar is recorded. You will receive an email with a link to the recording and with a link to the notebook and the presentation, the slides used. Okay, somebody's saying they have one more question. Can you please let me know what the question is?
So I'll stop sharing the screen now. Yeah, go ahead.
Yeah, okay. Okay, no, he just wants to ask about the link to the notebook. So you will be receiving an email within the next 24 hours with all that. Link to the recording, to the notebook, and link to the slide deck that Rajesh used.
So I just also thank you. So my manager just corrected me. If there is Spark 3. So if I show the screen, if you can see my screen. So if I change the kernel, there is 3.5 experimental available. So there is, but it's not there's still early stages of.
Yeah, it's still in like beta mode.
Yeah.
Perfect. Let's see. Yep, we don't have any more questions. So thank you, everyone, and thank you, Rajesh, for your presentation.
Sure, no problem. Hope folks find it useful, at least the methods that were used.
Okay, thank you.